I guess I better get started. Good morning, everyone. I am Dr. White. I am not his robot. Good morning. Welcome to another exciting morning of Chem 1211 with your host, Dr. White. I am not a robot. Happy Halloween, everyone. Have some candy. Hi, everybody. How do you like my new thing I got from Evil Genius Labs? Jason at Evil Genius said I bought this from him. Is this wicked? It's the CycloHex Lavalier. And no, I'm not a robot. Maybe I am. Is that wicked? Everybody see this on their screen, the CycloHex? Is that wicked? And Jason, I finally convinced him to get this out, but it's an awesome thing. He's got a lot of other cool stuff at Evil Genius Labs. And here's some of his creations. And he's done some amazing stuff. I have one of these too. But anyways, happy Halloween. Is that cool? This is my hobby, electronics. And I've got a battery right down here, which I think I'll shut off for a while. But you can get this at Evil Genius Labs. And Jason, it's got a PC in it, an actual computer in it. And is that wicked? All right, enough of this. Let me take this off, or I'll be playing with it for the rest of the day. I better take it off. Hold on one second. Actually, might be more than 1 second. All right, happy Halloween. If we were face to face right now, I'd be giving you this. Here, have some. Whenever there's Halloween, I'm teaching face to face. I've been doing this for a number of years. I always hand out candy. And if I teach a class where it's not on Halloween, but the day before, day after, I hand out candy. By the way, I buy and hand out candy, which this is what I'll be handing out later today, by my golden rule of candy, Halloween candy, which is don't give the kids any candy you wouldn't want for yourself. Can you figure out what candy I like? All right, let's get to work. Welcome to another exciting morning of Chem 1211 with your host. No, I'm not a robot, Dr. White. All right, this Wednesday, I will be giving quiz number 3 online. And as the announcement I did already last Wednesday, I'll talk about it again. This Wednesday, right after class around 11 a.m., I will send out the password for quiz number 3 PDF file. You will have until Thursday morning at 11 a.m. You'll have 24 hours to take quiz number 3 and upload your quiz answers as a single PDF file. Now, remember, I reserve the right to subtract the 25 points from quiz number 3 total for anyone who doesn't follow instructions, meaning uploading it as a single PDF file. And if you don't get your quiz number 3 answers uploaded on time. Now, quiz number 3 has 4 pages with 8 problems. It's worth 50 points. It covers only gases. And I recommend that you do the gas chapter practice problems and go back and look at the videos I've done on that. They're all on YouTube. And you'll be able to, I believe it's up already, download quiz number 3 PDF file, a periodic table the day before. I think I have it. If not, I'll have it by tomorrow morning. And by next Sunday or earlier, I'll post your scores for quiz number 3 on Blackboard before next Sunday, or by 1 p.m. next Sunday. I will send out an email with your individual points for each answer on quiz number 3. A week from today, the Monday after the quiz, I will go over quiz number 3 answers in our Zoom meeting, and I will delete it, cut it out. I like my special effects. Cut it out from the video, but if you can't come to the Zoom meeting, you can come to my office hours. If you can't come to my office hours, contact me and I will set up a special meeting on Zoom so you can get the answers. Now, I should tell you, normally, if I would be doing this face-to-face, I don't give quizzes. I only give 4 tests. And quiz 3 and 4 are really, when I do face-to-face, my test number 3. Quiz 1 and 2 would have been my test number 1. My test number 1 would be test number 2. Are you confused? Just ignore what I just said if you want to. All right. Any questions about quiz number 3? Well, I better do a review for quiz number 3. So let's do the review for quiz number 3. Thumbs up, people. Do you see quiz number 3 review? It says test number 3. It should say quiz number 3. I'll have to change this on Blackboard. Everybody see quiz number 3 on your screen right now. Review. Thumbs up, people. Thank you. All right, let's go through it. This quiz deals with gases. And one of the most important measurements you make with a gas is pressure. That's force per unit volume, which I'll never, or unit area, not volume, force per unit area, which I'll never ask on a test. But to measure pressure, there are different scales using different pressure devices like a barometer. And the first scale is millimeters of mercury, mmHg. And 1 millimeter of mercury equals 1 torr. Torr is the unit of pressure named in honor of the great Italian scientist Torricelli, who came up with the way of measuring pressure of gases. Now, another mistake. Wow, I got to really change this over. I have the same thing. All right, now it's correct, and I'll have to fix this on Blackboard. All right, 760 torr by definition since 1 millimeter of mercury equal 1 torr equals 760 millimeters of mercury equal another unit of pressure is the atmosphere, abbreviated by ATM. Not the place where you get money, ATM machine. But anyways, ATM atmospheres. These are all exact numbers. Now, an important measurement in gases is temperature. And temperature, when we use the gas laws, is always in Kelvin. And just to remind you, Kelvin is degrees C plus 273. Now, these things will be given to you on the last page of quiz number 3 as important information. Now, when it comes to gases, there's certain laws, mathematical relationships that are always true. And the first one is Boyle's law. I will never ask you to name a law, but Boyle's law is P1 times V1 equals P2 times V2. And P1 is the initial pressure, V1 is the initial volume. P2 is the final pressure, and V2 is the final volume. Now, the problems we went through in class, you'll be given P1 and V1. That's the volume you start out at. Then something will change, either P2 or V2. One of those two will be changing. And how do you know it changes? Well, if you had initial pressure, the pressure of a cylinder is so many millimeters of mercury and so many liters of the volume. What's the final, say, pressure if the volume is changed to another number? And when after something is changed, that will always be the final, either pressure or volume. And you'll be asked to find one of those two, and you'll solve for it using 3 variables. And I went through this, but let's do a quick reminder. Say you want to find P2, how do you solve for it? You want it alone on this side. How do you get it alone on that side? You divide, remember, anything divided by itself equals the number 1, meaning it's gone. So if I want P2 alone on one side, I want to get rid of V2s. To get rid of it when you're multiplying, divide by it. Remember, whatever you do to one side, you have to do to the other side. And anything divided by itself becomes the number 1. 1 times P2 equals P2 is equal to P1 over V1 divided by V2. And I like to write it over like this. And then now you can put in your numbers. And remember, on quiz number 3, it will say, please use proper significant figures for all calculated answers. Now, the other Charles' law I just briefly mentioned, it will not be on quiz number 3 or my test number 2. It won't. But the ideal gas law will. And it's probably my favorite mathematical relationship, one of them, or favorite law in chemistry, one of them. And that is PV equal nRT. And let me just show you something. Oh, I got it right on here. But anyways, everybody see important information on your screen. Thank you, Gianna. W. There are two Giannas today. All right. This is the material that will be given to you on the last page of quiz number 3. And the past students would have to memorize this. About 2 years ago, maybe a little longer by now, I came up with the conclusion by testing your memory in chemistry and your knowledge of how to use things in chemistry, or should I just tell your knowledge of how to use things in chemistry? I came up with the second one, which is why I'm giving you this. Now, the ideal gas law, PV equal nRT. Now, to use this, the different values, P is pressure, V is volume, N is the number of moles, R is the universal gas law constant, and T is temperature. But you have to have them in the right units. You will be given this. Pressure has to be in atmospheres, and you have to convert to that. Volume has to be in liters, and I'll always give you it in liters, or if you're asked to calculate it, it will be in liters. N is the number of moles. However, you'll be given grams of a substance. And in important information, quiz number 3, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights in grams. On quiz number 3, it will say under your name, please use proper significant figures for all atomic weights. Oh, it must be Dr. White robot came back again and made a mistake. Anyways, it will say, please use proper significant figures for all calculated answers. And it will also say, please use all atomic weights to 3 significant figures, just like test number 1. And use the periodic table that I will give you, and that's how you calculate moles. And we did this for test number 1, and look at a videos, number of them, where I've done this, and I went through a review, I think 2 videos ago. Now, the ideal gas law, PV equal nRT, for my class, you'll probably have to solve for pressure or volume. So let's do a quick review. The ideal gas law, PV equal nRT. Why don't you take this and solve for volume? And then I'll do it. So it's your turn. Give me a thumbs up when you're done. Again, all I'm asking you to do is solve for V with that equation. Give me a thumbs up when you're done. When you're done, you can have a Kit Kat. No, you can't. Here, take it. Ooh. Thank you, Gianna W. Thank you, Anna. We'll give everybody time to finish. All right. Thank you, Gianna J. All right. How do you solve for V? You want it alone on one side. Remember, anything divided by itself equals the number 1. So if I want to get rid of P, because I want V alone on one side, because that's what you're solving for, I'll divide by P. But anything you do one side, you have to do for the other. And remember, since anything divided by itself is 1 times V is V, this cancels out. Now, listen carefully. Common mistake. Students put in grams for moles. No, you have to convert it. R you'll be given. Temperature is always in Kelvin, and you'll have to convert that from centigrade or Celsius. Degrees C. Sometimes I use the old name. And pressure has to be in atmospheres, and you have to convert that from either millimeters of mercury or torr. That's a common mistake students make. They don't convert what you need in PV equal nRT, nRT and P, or nRT, and I'll give you V always in liters, to the proper units. Now, one other important thing about PV equal nRT, and that is it tells you about your car tires. And coming up in a number of weeks, even though I do like fall and winter better than summer, in winter, remember the temperature goes way down here in Chicagoland and other parts of the country. And in your car tires, there's gas. Either air, which is a mixture of nitrogen and oxygen gas, or in the last number of years, a lot of dealerships and car companies now fill tires with just nitrogen gas. But both are a gas. One's a mixture, one's pure nitrogen. When the temperature goes down, PV equal nRT tells us, since volume, the moles, and R are all going to be constant, the only thing that can change is temperature and pressure in your car tire. And if the temperature goes down, then the pressure goes down. So PV equal nRT tells us oops, wrong way. When the temperature goes down, the pressure goes down, it'll look like you got a flat tire. You don't. Now, in the summer, just the opposite happens. It was hot this summer, and other summers in Chicago, it's been very hot. Not as hot it was in 1995 when we had a really bad heat wave for 2 weeks. The daytime temperature never got below 100. Yep, in the summer, the temperature goes way up. And PV equal nRT, volume, moles, and R are constant in your tires. But if the temperature goes down, what happens to the pressure? And when I'm must be Halloween. The temperature goes up, the pressure goes up. So in the summer, when the temperature goes up, PV equal nRT tells us the pressure in your tires go up. And you should know this, not only for quiz 3, but for the rest of your life. When it's winter or summer, keep an eye on your tires. Now, I can't stress enough the common mistake on quiz number 3 is for PV equal nRT problems, 15 points. Ooh, I gave it away. You have to use the proper units, and you're going to have to convert things into the proper units. We've done all that, but I haven't done one right here, so let's do a quick one. First of all, this will be given to you in quiz number 3. All right, everybody see on your screen how many ATM atmospheres is 648.5 torr? Can you see that on your screen? All right, you can. Your turn. Why don't you try and solve for this, then I'll do it. And don't forget to use your, not only here, but on quiz number 3, your good buddy, your good friend, unit analysis. Bet you didn't think I'd get that in today. Wrong, I did. And give me a thumbs up when you're done. And remember, when you're done, give me a thumbs up. Thank you, Jana Jay. And we'll wait for everybody else to finish. Thank you, Gianna W. And thank you, Anna. My turn. All right, first thing, what are you being asked to find? What are you given? This number. And this is the only thing we have to start with, so I am. What units do we want to get to? Atmosphere. And if we had a ratio, two numbers, one over the other, to convert torr to atmosphere, what would that look like? Well, it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. And where do I get these numbers? From here. 1 atmosphere equals 760 torr. 1 atmosphere equals 760 torr. Now, these are both exact numbers because this is a definition. So before I pick up my calculator, I can highly stress you do this for quiz 3. Notice I have torr times atmosphere divided by torr. That's what I have up here, just the units. Remember, anything divided by itself equals number 1. Torr over torr, 1 times atmosphere is atmosphere. So these cancel out. I'm left with the right units. And now I can pick up my calculator, turn it on, make sure it's clear. 648.5 divided by 760. Hit enter. And my calculator gives me this number. Doesn't put down atmospheres, but I will. And on to quiz number 3, it will say, please use proper significant figures for all calculated answers. And this is all non-zero numbers are significant. 4 significant figures. These are exact numbers. They don't play a role in significant figure determination. And therefore, when you multiply and divide, the number with the smallest number of significant figures is how many significant figures your answer should have. Well, there's only one thing to look at, this, and it's 4. So you need to round this off to 4 significant figures. Your turn. Give you 10 seconds more to finish. Go. Go. Looking at seconds on my clock up there, and I gave you some bonus time. Let's do it. We want 4 significant figures. Keep the 8, keep the 5, keep the 3, keep the 2. They're all significant. The number to round off is 8. That's 5 or higher. So I drop that, increase this by 1. So it's 8.533 times 10 to the minus 1 atmosphere. Or you could have written it also like this. And that's how you do it. Remember, you should know how to do these conversions going from torr or millimeter to atmospheres are the other way around. And for PV equal nRT, you should know how to convert grams to moles. You should know how to convert centigrade, Celsius, to Kelvin. I will give you this formula. And finally, that leads us to the last law, and that's Dalton's law of partial pressures. And a partial pressure, which I'll never ask on a quiz or test, is the pressure of a gas in a mixture if it were alone. So P total, the total pressure, equals the sum of the individual pressures, P1, P2, P3, or how many gases you have, Pn. And if you want to solve for P total, you add the partial pressures of the individual gases in a mixture. Let's say you had two gases and you're given the total pressure and the partial pressure of P1, and you want to solve for P2. How do you get that alone on one side? You try that, then I'll do it. And when you're done, give me a thumbs up. What I'm asking you to do is get P2 alone on one side. Thank you, Gianna W. Thank you, Anna. I don't have to use your last initial because you're the only Anna. And thank you, Gianna J. All right, let's do it. How do we get rid of P1? Well, when there's an addition, A minus A equals 0. It's gone. And 0 plus anything else is that anything else. So to get rid of P1, because I want to solve for P2, I want it alone on one side, P1 plus P2 minus P1. And P1 minus P1 is 0 plus P2 would be P2. But whatever you do to one side, this, you have to do the other. So I will. And therefore, I can rewrite this. And I'll just rewrite it like this. If you're given P total and P1, you put the numbers and subtract, and that will give you P2. And I just wanted to show you, because we don't do this too often. We do a lot with addition, multiplication, division, and formulas to get a variable on one side, but not much for addition, subtraction. And with that, I'm done with quiz number 3 review. Any questions about quiz number 3? as with all my quizzes and tests, anything on a quiz or test, I have covered in our lecture at least twice, and the lecture part of lab at least twice, probably more than twice, but at least twice. All right, with that done, let me just close. Oh, excuse me. All right, let's get back to solutions. All right, everybody see molarity on your screen. Oh, no, I didn't. Oh, thank you, Gianna W. All right, last week we were talking about solutions. Remember, that's a homogeneous mixture of two or more components together, and concentration, how much of a solute. Remember, you had a solution, you have a solvent, the component present in the greatest amount, and all other components are called solutes. And if you make up a solution of a single solute in a solvent, you can also do it for mixtures. For this class, I'll keep it to a single solute. You have more than one solute and do molarity, but let's keep it to one. That's defined as moles of solute per 1 liter of solution. But 1 liter is equal to 1,000 milliliters. And the key for this class, molarity is moles of solute per 1,000 milliliters. And this will be given to you in quiz 4, important information, but that will be, I think, not this week, but maybe next week. I'll have to look at the schedule. Molarity is abbreviated by capital M. And the 1,000 is an exact number. So you should know molarity, moles of solute per 1,000 milliliters. Now, I'm doing some review because review is good for your grade, helps you learn material. And the question is, what does this mean? 3.11 capital M H2SO4. By the way, H2SO4 is sulfuric acid. Now, as soon as you see the capital M, that means molarity. And what does this mean? 3.11 moles of sulfuric acid, H2SO4, per 1,000 milliliters. I did cursive, sorry, SML. All right, let's have you try one. And what does 7.83 capital M KBR mean? Your turn. And all I'm asking you to do is, what does that mean? And give me a thumbs up when you're done. Thank you, Gianna W. And thank you, Anna and Gianna J. All right, what does this mean? Capital M, molarity. Molarity, moles of solute per 1,000 milliliters of solution. And therefore, this means 7.83 moles KBr, which is potassium bromide, per 1,000 milliliters of solution. All right. And the question is, what does this mean? And what is the solvent of the solution? And if you notice, capital M with a number on one side and a formula on the other means molarity. And molarity is moles of solute, in this case sodium chloride, per 1,000 milliliters of solution. So first of all, what does this mean? 8.7 moles sodium chloride per 1,000 milliliters of solution. But what's the solvent of the solution? This tells you right here, bracket AQ, close bracket, is short for aqueous, which means the solvent is water, aqua, or if you speak German, Wasser. And that's how you do it. Now it's time for a break, and I'll see you in 5 minutes, unless you get my robot again. Nope, it's me. I'll see you in 5. I'm going to get up and stretch. Well, that was more than 5. Sorry about that. Let's start again. And by the way, happy Halloween. This is for you. If I were in class with you now, every student gets 2 of them if they want. All right, we're talking about molarity. And I'm doing a sort of review, which is good for you. All right, everybody see 8 points. How many moles sugar are in 522 milliliters of a, thank you, of a 2.345, I see everybody can see it, capital M, sugar solution. So what I'm going to ask you to do, and we've done something like this, right here, write down what are you given and what are you being asked to find. Again, all I'm asking you to do right now, and give me a thumbs up when you're done, what are you asked to find and what values are you given? And let me remind you for quiz number 3, show your work. If you show your work and you make a mistake, and I can say, oh, you did this wrong, I can give you partial credit. If you don't show your work and put a number down, it's wrong, you get 0 points. That's a big 0. Thank you, Gianna W. Thank you, Gianna J. We'll wait for everyone to finish. All I'm asking you to do is, what are you given and what are you being asked to find? All right, my turn. What are you being asked to find? How many moles of sugar? What are you given? Well, how many milliliters of the solution? Remember, ml is volume, and we're given this number right here. And before I go any further, I see capital M. I know that's molarity. And what does this mean? 2.345 moles of sugar per 1,000 milliliters. That's molarity. Now, the only number I really have to start with is this. If there were some sort of ratio, what units do I want my answer to be in? Well, you figured it out. Moles of sugar. This is a sweet problem. Ooh. Don't forget, it's Candy Day, Halloween. All right, I'm going to let you do it, and then I'll do it. What number and unit go on top and bottom of the ratio? Your turn. Since we haven't finished this chapter, tomorrow I'll spend part of the lab finishing up this chapter. Again, what number go on top and bottom of that ratio? And units. Don't forget to use your good buddy, your good friend, unit analysis. And don't forget, if you're going out trick-or-treating tonight, look both ways when you cross the street. Be safe. That reminds me, I always try when I was younger to go to the bank and say, trick or treat, and hopefully they give out money. They never did. Shucks. All right, I'll give you another 30 seconds. Go. Five, four, three, two, one. Time's up. All right, how do you do this? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to, the units go on top. Whatever we're trying to get rid of, the units go underneath. Sounds familiar. I hope it does. And I'm going to write those. Moles, or sometimes I forget, I don't put the S there. Mole sugar and milliliter. And where do we get these numbers? From the molarity. What does that mean? 2.345 moles of sugar per 1,000 milliliters. Already got that there. And that's where you got the numbers for this ratio, from the molarity. And now, before I pick up my calculator, I'm going to sneeze. Hold on. It's a slow October sneeze. I think I stifled it. I'm going to look at my units. Notice I have mils, milliliters, times moles of sugar divided by milliliters. And remember, anything divided by itself equals number one, meaning it's crossed off. Milliliters divided by milliliters, 1 times moles equals moles of sugar. So I now know I have it set up correctly. And milliliters cancel out. I'm left with the number I want. And now I'll pick up my calculator, turn it on, clear it. 252 times 2.345 divided by 1,000. And my calculator gives me this number. Ten to the 0. 10 to the 0 is the number 1. So what I really have is this number. And now, remember on quiz 4, just like I'll do this Wednesday on quiz 3, please use proper significant figures for all calculated answers. And this is 3 significant figures. All non-zero numbers are significant. Same thing here, but it's 4 significant figures. And the 1,000 is an exact number that does not play a role in determining significant figures. And now I say, when I do multiplication and division, the number with the fewest significant figures that you multiply and divide by, is the number of the significant figures in your answer. So the lowest number is 3. I'm going to let you round this off to 3 significant figures, and then I will. Your turn. I'll give you more than 3 seconds. Go. Remember, all you're doing is rounding off the 3 significant figures. Thank you, Gianna J. Thank you, Gianna W. All right, my turn. Keep the 1, keep the 2, keep the 2. That's our 3 significant figures. Use the 4 to round off. That's 4 or less. I'm going to drop that. And the answer would be this. And that's how you do it. Now, in real life, you make up what's known as stock solutions. All right, everybody see on your screen 10 points? And the question is, how many grams of HCl, hydrochloric acid, thank you, Gianna J, are needed to make, spelling error, to make 756 milliliters of a 1.11 capital HCl solution. So what are we being asked to find? Grams of HCl. What are we given? 756 milliliters of a solution, and the molarity of that solution should be 1.11 molar hydrochloric acid. Now, there's no way I can go from milliliters to grams. You can't. There's no way. So what do? You need, let me do it in this color. You need 2 steps. And those 2 steps are step 1. You go from grams of A to moles of A. Step 2, moles A. Oh, wait, Dr. White just had a brain freeze. Let's try this again. I should have looked at important information. Quiz number 3. We go from milliliters to moles. Of A, and then you'll do moles of A to grams of A. See, even Dr. White gets messed up. Must have been that robot did it. All right, let's look how to do this. Step 1. Milliliters to moles. Well, the only thing we have in milliliters is 756 milliliters. We want to get to eventually grams of HCl, but the first step we have to go to moles, in this case, HCl. And how do you do that? Use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to, the units go on top of the ratio. Whatever I'm trying to get rid of, the units go underneath. And I'll write those in. And where do I get these numbers? From what this means. Capital M means molarity. So 1.11 capital M HCl means 1.11 moles HCl per 1,000 milliliters. So the number goes here, 1.1 moles of HCl per 1,000 milliliters. Now, before I pick up my calculator and I set this up right, I'll look at the units, milliliters times moles of HCl on top. And I'm doing this, you don't have to do it yourself. Maybe you should, because a lot of people on test number 1 messed this up. And notice milliliters divided by milliliters, anything divided by itself equals number 1. And I'm left with the units I want. And now I'll pick up my calculator, clear it. Do the multiplication division. My calculator gives me this answer. And remember, on all my quizzes and tests, it says, please use proper significant figures for all calculated answers. Boy, this is thirsty work. And therefore, this is 3 significant figures. All non-zero numbers are significant. This is 3 significant figures. The 1,000 is definition, exact number. When you multiply and divide, you get the same number of significant figures as the number with the fewest significant figures, which in both cases 3. So I'm going to round this off to 3 significant figures. They're my 3 significant. Use the 1 to round off. That's my 4th one. That's what I use to round off. As 4 or less, I'll drop that So the correct answer at this step is this. Now, I'll remind you at the end, you can round off at the end or round off at each step. I'm a round off at each step person, but I'll calculate it both ways on a quiz or test. Now, are we done? No, we want to get the grams of HCl. And now we have to do step number 2. Moles of whatever we calculated to grams of that. Well, we have 8.339 times, and that's a 9, 10 to the minus 1 moles of HCl. And we want to get the grams of HCl. You hopefully learned this for test number 1, and you'll need it for quiz number 3 and quiz number 4, which I'm doing now, material 4. Use your good buddy, your good friend, unit analysis, whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And I'll write those units in. And where do I get this? In important information, quiz number 3 and also quiz number 4, it will tell you 1 mole of a compound equals the molecular weight in grams of the compound. And the molecular weight in grams of the compound equals the sum of all atomic weights in the compound. And we have an HCl, 1 hydrogen, 1 chlorine. And atomic weight of hydrogen, the 3 significant figures, we've done this many times. You look on the periodic table, this is the 1.01. For chlorine, 35.5. You get 36.51. When you're adding, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. This has 2, this has 1. Your answer should have the same number of significant figures to the right of the decimal as the number that has the fewest to the right of the decimal. So rounding this off to 1, because 1 is less than 2, keep the 5, use the 1 to round off, and therefore the molecular weight of hydrochloric acid, HCl, is 36.5. And since 1 mole of a compound equals its molecular weight, I can do that. Now, before I continue, I have moles hydrochloric acid times grams hydrochloric acid divided by moles hydrochloric acid. Anything divided by itself equals number 1. It's gone, so I can cancel it. I'm left with grams of HCl, which is I want. And now I'll pick up my calculator, clear it. Remember the minus sign for 10 to the minus, that was a 1. I forgot to write it. Is this on the keypad, not the minus on your calculator for subtraction. And my calculator gives me this number right here. And this is 3 significant figures, all non-zero numbers, 3 significant figures. The 1 is an exact number. When you multiply and divide, you get the same number of significant figures in your answer that has the fewest significant figures. In this case, that's, oh, I'm in my rut again, 3. Keep the 3, keep the 0. Remember, zeros between non-zero numbers, zeros after decimal are always significant. Keep the 6, that's my 3. Use the 2 to round off, that's 4 or less. And the answer is that. And that's how you do the 2-step. Step 1, go from milliliters, which are given, to moles. As you see here, you need to know this right here. What does capital M mean? That's where you get the numbers here. Step 2, you go from moles of whatever you're trying to find to grams of whatever you're trying to find. And you will be given 1 mole of a compound equals the molecular weight of the compound, and the molecular weight is the sum of the atomic weights of the compound. And that's how we got this right here. And that's how you do it. And tomorrow I'll go through one more of these. Because hint, you should know how to do this. All right. Thumbs up, people. Do you see dilution? All right, thank you. All right, watch closely. Click. Will this be on quiz number 4? No, but I'd still like to cover it. And dilution is the process in which you add solvent to solution in order to make the concentration lower. If it's too high, you add solvent, and that dilutes it, makes the concentration lower. And to determine how much to add, there's a formula. C1 times V1 equals C2 times V2. C1 is the initial concentration, V1 is the initial volume, and C2 is the initial concentration, and the final concentration, C2, and V2 is the final volume. Now, generally, you're going to be trying to find what should be the amount you add, which is V add. And you first do 2 steps. This won't be on the test or quizzes. You find the volume from V2 from this equation, and then you find how much you add, V2 minus V1. And that's how you do dilution. Now, interesting story. Don't tell anybody I'm telling you this. I consult. And I have this one company every once in a while, they make a solution, they mess up, and it's too concentrated. They added way too much solute to the solution or the solvent when they made it up. And we're talking a lot of money. $50,000, $60,000 could go down the drain if they don't fix it. Well, the company people who should know how to do this are, how should I say this politely, scared to do it and make a mistake. So they call me up, and because I've showed them how to do it originally, and say, could you do this? Tell us how much we should add to dilute it. I said, sure, let me get back to you in a little while. I got to do a lot of calculations. Not really, but I tell them that. And I take about an hour and I charge them a half hour, a couple $100. And I say, here it is. I said, by the way, you can do it yourself. And I show them and they say, no, we'll let you do it. And it's an easy couple $100. And it's using this formula. Remember, switch was off, dilution is when you add a solute solvent to make the concentration of the solution lower. All right, switch is on. If I had a dial that goes to 10, I've just turned it to 20. Now, there's certain things in our life that you say, oh, that's a solution. It's not. And what's an example? Well, a solution, if I put sugar in here, that would be a sugar solution. And there's another type of mixture that's not. And how can you tell it? Oh, it's time for Dr. White to show off some of his fancy flashlights. This is made by the premier flashlight maker in the world, a guy named Hank Wang in China. He has a big following throughout the world. Obviously, I'm one of them. And a solution is when you can shine a light through it. Now, the other type of thing, if I had a glass of milk here, like my hand, you can't see the light going through it. Is this cool? Let's see, can you see it? No, you can't. You sort of can. See it changing colors? They've got auxiliary. Now, I got more from Hank too. So if you have a light and it won't go through a mixture that's homogeneous, that's not a solution like this would be. By the way, this is really fancy. Wait a second. It's also got red. Yes, I'm a flashlight collector nut. Anyways, what do we call one that light will not pass through? It's called a colloidal dispersion. And what is a colloidal dispersion? It's a dispersion of small particles in one substance in another substance dispersed. And it's mixtures in which materials are not truly dissolved, but are dispersed. Now, I won't ask you, but instead of solute and solvent, we use dispersed phase and dispersing media. Now, what are examples of colloidal dispersions? Being subtle again on Halloween, you should know some examples. Milk is an example of a colloidal dispersion. Light won't go through it because the particles that are not truly dissolved scatter the light and stop it from going through. Latex paint, which you can buy at your home improvement store nowadays or other stores. And do not try this at home or anywhere else, but your blood is not a solution. It's a colloidal dispersion. Why? Because the water in there doesn't truly dissolve the fat or protein or other things that are in your blood. Now, I think I am going to see. Wow, that took a while to come out. Excuse me. So you should know milk, latex paint, blood are all colloidal dispersions. And how can you tell that? They do not disperse light, or they do disperse light. And you should know that colloidal dispersions are determined. One way to determine it is they disperse light. Oh, I get to show off my flashlight. This is a little one by another company, and this is probably one of the hottest flashlights in the world now. It's the Workless TS10. It's a tiny little flashlight. And it's a bright sucker. This is really bright, and it's tiny. But anyways, remember, colloidal dispersion, light doesn't go through. Solution, light will go through. And while you're looking around your house, you open up the refrigerator, take your flashlight, and shine it through things. Guess what? It won't go through ketchup. It won't go through mustard. Guess what they are? Colloidal dispersions, not solutions. So if light will not go through something, that's a homogeneous mixture of two or more substances, it's a colloidal dispersion. Now, switch is on full. All right, let's talk about boiling and boiling points. I hope you all have in your life have seen water boil, whether you've done it or someone else. I once had neighbors, and one of the neighbors, when I was in grad school, and across the hall from me were these four girls who were sharing an apartment. I had my own. I was in grad school. I was making some money. And one of them was from a very rich family from Brazil. I mean, really rich. They had their own servants, and she had never seen water boil before. She never cooked before. But anyways, what is boiling? It's a special form of what we call evaporation, where conversion from liquid state to vapor state, meaning a gas, occurs within the body of a liquid through bubble formation. Now, I'll never ask you what is boiling, but I better warn you, it's time for some artwork from Dr. White. Warning, warning. Let's say you have a hot plate. You could do it on your stovetop. And here you have a pot. Don't laugh too hard. Don't break a rib. And it's got water in it. And when you turn on the heat, all of a sudden, after a while, you'll start seeing bubbles form. And they rise to the surface and collapse. Boom, collapse. They don't go boom, but they collapse. And what they give off, what's inside the bubble, if this is water vapor. And the water vapor is a gas. And that releases gas above the liquid of water, liquid level of water. Now, out here, we have air. And that's a gas too. Hopefully you knew that, but just in case you didn't. And both have pressures. And you can measure the vapor pressure of the water, the bubbles collapsing. You can measure the vapor pressure of the air. Now, boiling point is the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric external pressure of the liquid. So if we go back to my exciting pot here, and if we had a thermometer, and we could measure temperature, the boiling point, which is a temperature of a liquid, is when atmospheric pressure equals vapor pressure. This pressure is equal to that pressure, and we call that the boiling point. Now, a normal boiling point, or boiling point we normally consider, is the temperature at which a liquid boils at 760 millimeters of mercury, 1 atmosphere. Now, if you're living in Chicago, or better yet, Chicagoland, which we all are, we're at, normally, unless there's a storm coming through, we're at sea level, essentially, and normally the pressure is 1 atmosphere, 760 torr. And that means the boiling point of water is 100 degrees C. Now, remember, let's see how much time. Oh, I got time. Remember that the boiling point is the temperature at which vapor pressure equals the atmospheric pressure. Now, interesting thing about our planet, Earth, is when you go higher up altitude, the atmospheric pressure goes down. Higher up altitude, atmospheric pressure goes down. So if you go to, I'm thinking of a city. Hold on, I've got to, I just thought of a good city. If you go to Denver, you're at a higher atmosphere, higher level altitude. Three dots means therefore. Water has a lower boiling point. And this is something you should know. If you go to Denver, where you're at a higher elevation and a lower atmospheric pressure, it takes less energy to have the vapor pressure equal the atmospheric pressure. And assuming there's no storms going through, the boiling point of water in Denver is 92. And if you're boiling noodles or rice, and I have friends, long time ago, I used to visit in Denver, they've moved since, You could see on the package of noodles or rice you would buy where you have to boil them longer because you're at a lower temperature to cook the food. Now, let's go to the top of the Himalayas. That's the highest point on our planet, I believe. And if you go to the highest, like Mount Everest, the boiling point of water is 68 degrees C. That's the top of the Himalayas. Is that amazing? In Chicagoland, at sea level, no storms going through, you're talking about 100 degrees C. If you go higher up in altitude, less at lower atmospheric pressure, and therefore you have lower boiling point because you need less energy in the water to be heated to equal the vapor pressure of the atmosphere it's in, which is why when you go to the top of the Himalayas, Mount Everest, you can boil water at 68 degrees C, but you got to cook your noodles a long time to get them cooked or use a pressure cooker. And with that, I'm out of time. Don't forget, have a happy Halloween. Here, this is for you. I wish I could give it to you. And if you see my robot, send him back to me. I think he got away somewhere. I don't know where he went. And remember, office hours are Tuesday, Wednesday from 6 to 7:15. If you have special questions, I have time, email me and I'll see if I can set up a Zoom meeting with you. If not, welcome to my office hours. With that, I'll say, have a happy Halloween. Gang gesund. Bye now.